Bagasse is the fibrous matter that remains after sugarcane or sorghum stalks are crushed to extract their juice. It is used as a biofuel and in the manufacture of pulp and building materials. Agave bagasse is a similar material that consists of the tissue of the blue agave after extraction of the sap. Production, storage and composition. For each 10 tons of sugarcane crushed, a sugar factory produces nearly 3 tons of wet bagasse. Since bagasse is a byproduct of the cane sugar industry, the quantity of production in each country is in line with the quantity of sugarcane produced. The high moisture content of bagasse, typically 40 to 50%, is detrimental to its use as a fuel. In general, bagasse is stored prior to further processing. For electricity production, it is stored under moist conditions, and the mild exothermic reaction that results from the degradation of residual sugars dries the bagasse pile slightly. For paper and pulp production, it is normally stored wet in order to assist in removal of the short pith fibers, which impede the paper-making process, as well as to remove any remaining sugar. A typical chemical analysis of bagasse might be: cellulose 45 55%, hemicellulose 20 25%, lignin 18 24%, ash 1 4%, wax is less than 1%. Bagasse is an extremely inhomogeneous material comprising around 30 to 40% of pith fiber, which is derived from the core of the plant and is mainly parenchyma material, and bast, rind, or stem fiber, which comprises the balance and is largely derived from sclerenchyma material. These properties make bagasse particularly problematic for paper manufacture and have been the subject of a large body of literature. Use. Many research efforts have explored using bagasse as a renewable power generation source and for the production of bio-based materials. Fuel. Bagasse is often used as a primary fuel source for sugar mills. When burned in quantity, it produces sufficient heat energy to supply all the needs of a typical sugar mill, with energy to spare. To this end, a secondary use for this waste product is in cogeneration, the use of a fuel source to provide both heat energy, used in the mill, and electricity, which is typically sold onto the consumer electricity grid. The resulting CO2 emissions are equal to the amount of CO2 that the sugarcane plant absorbed from the atmosphere during its growing phase, which makes the process of cogeneration greenhouse gas neutral. In many countries, sugar factories significantly contribute green power to the electricity supply. For example, Florida Crystals Corporation, one of America's largest sugar companies, owns and operates the largest biomass power plant in North America. The 140 MW facility uses bagasse and urban wood waste as fuel to generate enough energy to power its large milling and refining operations as well as supply enough renewable electricity for nearly 60,000 homes. Hawaiian Electric Industries also burns bagasse for cogeneration. Ethanol produced from the sugar in sugarcane is a popular fuel in Brazil. The cellulose-rich bagasse is being widely investigated for its potential for producing commercial quantities of cellulosic ethanol. For example, BP is operating a cellulosic ethanol demonstration plant based on cellulosic materials in Jennings, Louisiana. Pulp, paper, board and feed. Bagasse is commonly used as a substitute for wood in many tropical and subtropical countries for the production of pulp, paper and board, such as India, China, Colombia, Iran, Thailand and Argentina. It produces pulp with physical properties that are well suited for generic printing and writing papers as well as tissue products, but it is also widely used for boxes and newspaper production. It can also be used for making boards resembling plywood or particle board, called bagasse board and xanita board, and is considered a good substitute for plywood. It has wide usage for making partitions, furniture etc. Much industry has patented a method of converting bagasse into cattle feed by mixing it with molasses and enzymes and fermenting it. It is marketed in Thailand, Japan, Malaysia, Korea, Taiwan and Middle Eastern Australia as fiber-rich. Xanita, a South African company, mixes 30% bagasse cellulose fibers in with recycled kraft paper fiber to make ultra-lightweight composite boards. These are sold as an environmentally friendly, formaldehyde-free alternative to MDF and particle board. Health impact. Workplace exposure to dusts from the processing of bagasse can cause the chronic lung condition pulmonary fibrosis, more specifically referred to as bagasse. See also, biofuel, bioenergy, corn stover, references. Further reading, The Potential of Bagasse-Based Cogeneration in the U.S., Kevin Ho, Columbia University, 2006.